All right, here is a review video for the test. Reminder, you do not have to watch this video. You can scroll through it to find the parts that you think that you actually need. Or again, not watch it. I think it's going to be helpful for you. It does answer the, I believe, 3 people who asked to see specific problems from yesterday. We will cover examples like them. If you want to see those specific ones worked out from the review yesterday, let me know and I can get on that. But this covers what they were talking about, right? So the first kind of questions, and in general, this is going to be more or less in order, so I might go out of order once or twice here for what it's going to look like on the test. So early in the test, you're going to ask for a geometric mean. Geometric mean between 2 numbers like 8 and 32. The geometric mean between 2 numbers is just that you have set up 8 over x equals x over the other number. So 8 over x equals x over 32. This gives us x squared equals 8 times 32. That's when we cross multiply. And then we can take the square root of both sides. 8 times 32 is 246. And the square root of 256 is 16. Again, you can use a calculator for that. You can actually put the square root of 8 times 32, just make sure that they're both under the square root when you do it, and we should get 16. Next questions will be something like find x given CD is 4 and BD is 9. Now the diagram that looks something like this. B, C, D. There'll be an X in there. It will also tell you that the triangle is a right triangle and this is an altitude. So what you know when it says that, the triangle is a right triangle and this is an altitude. Angle A is a right angle, and this angle down here is a right angle. So what you should be seeing when you do this problem is it is telling you that CD is 4. So CD is 4, right? BD is 9. So the length here is 9. Then we're using the geometric mean altitude theorem because x is an altitude. We get 4, one of the 2 parts over the altitude x equals the altitude x over the other part. Now it's just a geometric mean like we just worked on. So we have x squared equals 4 times 9, which is 36. Taking the square root of both sides, we find that x is 6. Next, we'll have some find value of x given angle A is right, something like AC is 6 and AB is 8. So A, B, C, angle A is a right angle, AC is 6, AB is 8. Since it's a right triangle and we know 2 sides, to find this third side we use the Pythagorean theorem. A squared plus B squared equals C squared in a right triangle, where C squared is the hypotenuse. The hypotenuse here is CB. Sorry, we would have had an X there. CB or X. So we have 6 squared plus 8 squared equals X squared. 6 squared plus 8 squared, 36 plus 64 is 100. And the square root of 100 is 10. You'll be asked a similar question to that. So we're going to use the same information, well, some of the same information, A, B, and C. So we're going to get the same kind of, or the exact same triangle here. But let's say that we had AC is 6. Do it the other way. Let's do AB is 8. BC is 10. And we're trying to find AC. So again, same thing. It's a right triangle. Trying to find AC. AC is not the hypotenuse, so it's a little different than the last one. But we know that AB is 8. Hypotenuse is 10. All right, so we set it up as x squared plus 8 squared equals 10 squared. 10 squared is 100, minus 64 is 36. And we get x is 6. So both of those kind of problems will be on there. One where you're finding the hypotenuse, one where you're finding one of the legs. You're finding the hypotenuse. It's the 2 legs each squared summed. And if you're finding one of the legs, then you need that leg squared plus the other leg squared equals the given hypotenuse squared. Again, this is a Pythagorean theorem. And it's supposed to be trying to make sure that you just know what this is and be able to use it in relatively basic ways. All right, next, find the trig ratio given. Round to the 100th. Right. So in the notes for today, I make a comment. Make sure you read the directions. 100th again is 2 points after the decimal. Right. So these ones should be relatively simple. It's going to give you a trig function, and it's going to give you an angle measure. So it's going to be something like the tangent of 21, right? So trig function, the angle, all you do is type tangent 21 into the calculator, do about 0.3838, but we want to round to the 100th. The 100th is the second spot after the decimal, right? And then to decide if we keep it or round up, we look at the next digit. If the next digit is 4 or lower, we leave it. If it's 5 or higher, we round the second number up. So it's a 3, so we leave it at 0.38. Do one more of those. Again, I could do cosine, sine, tangent. You can do any angle measure that I want. So I'm not going to do everything that could be there, but let's look at the sine of 28. So again, whatever calculator you're using, type in the sine. 28. Make sure again that your calculator is in degrees. If it's in radians, it will do this all wrong. So what you should do is check something like these two. If you're getting answers that are different than mine, your answers are wrong, not mine, which means that we need to fix your calculator before you take the test. Coming to me after and saying, oh, I think my calculator was in the wrong setting, the wrong mode after the test, sorry, you're out of luck, right? So sine of 28 in our calculator, we get about 0.46947. Again, we're rounding to the hundredth, so just these two digits. And then we look at our next digit, which is a 9. Since it's a 9, we round up the 6, and we get about 0.47. The next set of questions will ask for angle measures. Angle measure to the whole degree. Right, so these are whole numbers. We're going to round to the whole number. We have the sine inverse of 3/11. Again, in your calculator, there should be a way for you to do the sine inverse. On a regular calculator, it is typically, there's a second button, written like this, second button. It's usually in the top left-hand corner area. You would press that, and then the regular sine button, which will give you the sine inverse. So sine inverse, 3/11. Again, it's just typing that into your calculator. You get out 15.8766. We are going to the whole degree, so we don't care about these three numbers at all. Right? No matter what they are, we don't care what they are. We care about the one right after the decimal point, which is an 8. An 8 is bigger than 5, and so it's going to round up our whole number from 15 to 16. Right? So we are rounding it up because of the 8. Right? The other way to kind of think about it is 0.8 is closer to 1 than 0. Right? That's why it rounds up to 16 rather than staying at 15. Right? Is 15.8 closer to 16 or 15? It's closer to 16. That's why we rounded up to 16. Tangent inverse of 9/11. Again, it'd be second tangent if you're using a regular calculator. Otherwise, some of the online things have something like an inverse button that you would push. That would change the tangent button to a tangent inverse. You should know that by now, since we've been doing this for a while. 39.289. Again, since we're rounding the whole degree, we don't care about the 8, 9 at all. Do not do anything with them, right? The only thing we care about is this number right after the decimal, the way it is right now. 39.2. 2 is less than 4, so it doesn't do anything to our 39, and we get 39. All right, decide if these lengths can make a triangle. Obtuse, right, or acute, right? I think you guys know this one well enough. The question itself, the question will be slightly different than that wording wise, but you're basically deciding whether the three sides I give you make a obtuse, right, or acute triangle, right? So we'll look at three sides, 3, 8, and 10. So first question, can you make a triangle? Yes, because 3 plus 8 is 11. 11 is bigger than 10, right? So is this triangle obtuse, right, or acute? We plug it into basically the Pythagorean theorem, except that Pythagorean theorem is only true for a right triangle. This is trying to tell what kind of triangle. So we have 3 squared plus 8 squared, and we want to see if it's equal to 10 squared. This is 9 plus 64. That's 73. 73 is less than 100. What you want to see here, right? A squared plus b squared and c squared. C squared is bigger, right? C gets bigger. That means the angle opposite C is bigger, right? If we're breaking that 90-degree right angle, because C squared is getting bigger, we have gotten a larger angle, which is obtuse. Eight, 8, and 10. How about 8, 8, and 10? Well, here, right, again, filling it in, we get 8 squared plus 8 squared is 10 squared. This is 64 plus 64, and that is 120, 138, 128, 128, which is greater than 100. So a squared plus b squared is bigger. So the triangle's acute. And if we had sides like 6, 8, and 10, we already looked at this, right? That's 6 squared plus 8 squared equals 10 squared. 6 squared plus 8 squared is 100. Equals 100. They're the same. That's a right triangle. And notice I don't have a lot of room here. 3, 4, and 7. 3 plus 4 is 7. 7 is not bigger than 7. This is not a triangle. Again, these are from a multiple choice drop-down menu. So the only choices you have are obtuse, right, acute, or this other option. I think it's cannot form a triangle or something like that in the actual test. All right, let's see. Again, it'll say angle A is a right angle. Angle's a right angle. And then this would be something like, tell you AB is 8. AC is 15. And BC is 17. And it'll ask for the ratio of the given sign, of the given trig function, or something like that, right? Round to the 100th. All right, so again, what this is saying, it may be helpful for you to just draw this triangle out and then fill in the information we have. So we have AB is 8. AB is 8, that's the segment AB. AC is 15. BC is 17. Right? And then it'll ask a question like the cosine of C. Right? And then this would be something that maybe you would show in your work, right? The cosine of C, so you'd write the cosine of C. Well, the cosine of C is the adjacent 15 over the hypotenuse 17. And 15 over 17 is about 0.8823, and then it keeps going. Again, the only thing we care about are these two numbers, and then third number. Third number is less than 5, and so we leave it. So we would just write 0.88 here. Might also ask for something like the sine of C, right? The sine of C, again, is opposite 8 over 17. And again, it's asking for the ratio here, not the measure of the angle. So we do not actually type in the sine at all. It is just saying that this is 0.47. The next number after the 7 is a 0, and so we would leave it here, rounded to the 100th. Again, you could also have a tangent. How about the tangent of B, just to mix it up a little bit? Tangent of B is the opposite side, 15 over the adjacent 8. And 15 over 8 is 1.875. But if I'm asking you to round to the 100th, we do not write this, right? You notice that the number after the 100th place is a 5, and so that rounds up the 7. So this is rounded to the nearest 100, 1.88. Sorry, I went off my page just a little there. Hopefully we didn't miss too much. This is directly related to SOHCAHTOA, right? So this is the main concept of what I'm testing on this part, is our understanding of the sine being the opposite over the hypotenuse, cosine being adjacent over the hypotenuse, and tangent being opposite over adjacent. The next part, this is 30, 60, 90s, and 45, 45, 90s. So you'll be given a diagram like this. C. And it'll say something like AC is 17. AC is 17. Find BC. All right. It might say find BC to the round to the nearest 10th. It wouldn't have to. All right. So for filling in, AC is 17 in the diagram, right? Where is segment AC? It's right here. So that is 17. We're looking for BC, which is the hypotenuse, right? So we're going from the 17 is the short side because it's across from the 30-degree angle. So to go from the short side to the hypotenuse, we multiply by 2. And we get 34. Right. There'll also be a question, not in the same question, but a different question then, but the same kind of diagram, and it'll ask you to find AB. This is probably to the 10th. All right. AB is the long leg of our triangle, right? Because it's across from the 60-degree angle. To go from the short leg to the long leg, we multiply by we multiply that short leg by the square root of 3. So we get 17 square root 3. However, we need this to the 10th, so we plug it into our calculator. 17, take the square root of 3, and we get about 29.4 It's 29.44. Since the next number is a 4, it does not round this up, so we get left with just 29.4. Right? Again, just checking to make sure your calculator works right. I would type this into your calculator and make sure that you get 29.4. If you get something different, it's because your calculator is reading what you're typing differently. For instance, it might take the square root of 17 times 3, which is not what we want to do here. Right? Uh, 45, 45, 90. And this one might say something like AC is, well, I use 17 again, 17, right? It could be anything. It doesn't really matter here. So AC is 17, right? Again, if you draw your diagram, I think that'd be helpful for you. AC is 17. To go to the hypotenuse and a 45, 45, 90, we multiply the short leg or the leg by root 2. So find CB. CB is 17 times the square root of 2. 17 square root of 2 is about 24. Again, this would be to the 10th. We get 24.04. The 4 does not round up our 0. You could answer it as 24.0. You won't get it wrong if you do that. It may change your answer just to 24, which again is fine. So 24 or 24.0 for that. So again, just multiplying that short leg by root 2 to get to the hypotenuse. And we're to the last questions. These are probably the ones that we're going to consider to be possibly the most difficult for us. So we're going to have a diagram, A, B, C. And we kind of had one that looked like this already, but it only asked for one of the parts, right? And the other one we did, it only had X in it and only asked you to find the value of X. This one has X, Y, and Z. In different problems on the test, it will ask for different parts. So make sure you are reading the directions, whether it asks for X, Y, or Z, because that question will change that way. Here, the directions will also tell you that angle CAB, it'll be written angle CAB and angle, right, always want to write and there, and angle ADC are right angles. And so this angle and this angle are right angles. So we have a right triangle with its altitude drawn in, right, from the right angle. And then it'll be like find X given CD is 5 and BD is 9. And I would suggest you draw your triangle and you write those in. CD is 5, BD is 9. This is the geometric mean altitude theorem. So we have the altitude of X. The two numbers that are here form a geometric mean with the altitude. That is 5 over X equals X over 9. Or X squared equals 5 times 9, which is 45. And the square root of 45 is about 6.7. I don't have it written down here. I believe these ones go to the 10th, not the 100th. So 6.7, it's 6.708, right? We don't care about the 8, so we have 6.70. 0 is obviously less than 5, so it stays the same at 6.7. In a follow-up question, or a question after that, or in the same section, I think it's in the same section, it might ask you to find y, right? This is also a geometric mean. However, now it's a geometric mean of hypotenuses and sides. So the hypotenuse of the large triangle is 14. That's over the hypotenuse of the triangle with y in it. The smaller triangle with y in it, that is y. Y is also a side of the triangle, the large triangle, over the part that's not x in the small triangle here, right, which is 5. Okay, y squared equals 5 times 14. Take the square root of both sides. Square root of 5 times 14 is about 8.4. Again, you'll get 8.36. Since 6 is bigger than 5, it rounds the 8.3 up to 8.4. Z is similar to that. So we start with 14 over Z. So again, it's the hypotenuse of the whole over the hypotenuse of this other triangle over here. 14 over Z equals, Z is also a part of the large triangle over the part of the smaller triangle, which is DB, which is 9. So we get Z squared equals 9 times 14. Square root of both sides. And we get about 11.2. It's 11.22. Since 2 is smaller than 5, we leave it and we get 11.2. All right, there is only one kind of problem that I did not look at here, which was the law of sines. Do not plan to go over that one. That one was is being taken directly from your homework assignment. So if you had questions on the homework assignment, you should go back and look at it. In general, again, the law of sines says the sine of an angle over the side opposite it equals the sine of an angle over the side opposite is the sine of some angle over the side, let's just see, side opposite it, right? But those problems come from your homework assignment. I know I talked a little bit fast throughout the video. The reason was because I did not want it to take forever for you to get through. So hopefully if you knew something, you just scrolled through, or you found the review of the things that you knew to be helpful as well. Best of luck on the test. If you have any other questions, send me an email before you take the test.